Hey everybody. So this is actually the last sort of non-R coding video that we have for this quarter. So we've had these on GitHub and project management. And this last one's about spreadsheets and why spreadsheets in particular. I mean, the high level reason is that for most of us, spreadsheets are ultimately how we store our data, not necessarily in Excel, and we'll talk about what I mean by that. But in general, we're talking about flat files, right, that have rows and columns, and you could envision opening up in Excel or a similar software program and doing work on it. And so, right, we think about spreadsheets a lot in R because often we're either trying to read a spreadsheet in or write some sort of spreadsheet out. And then if you're like manually collecting data, you're typically filling out some sort of flat file, at least initially, to fill out the data, or even if you're somewhat automating it, like if you have a Qualtrics survey or a Google Forms survey, it's still ultimately, when you export those results, it shows up in some sort of spreadsheet. And so thinking through sort of best practices for how to organize those, how to enter data into those, and then how to read and write them in and out of R can save you a lot of heartache in the end. So the first high level thing is right, you don't ever want to take your raw data and just start overwriting it. So anytime you're starting with something that is important and you're going to make some changes, make a copy and then start making those changes. That doesn't necessarily mean you can't then like save back over the master later, right? If the master was like truly, if the original was truly like a bad data, you could overwrite it. But at the very beginning, right, until you're sure, you always want to make a copy before you make any changes, and probably just go ahead and save the old copy as well, so you can kind of keep tabs on things. The other thing you want to do as you're doing that, and this is something a long time ago, people probably didn't do this, but increasingly as when we as scientists go to publish, we're asked to provide not only our data, but all the methodology steps we've taken that would allow someone to replicate our work for full transparency. And so keeping track of those changes so you can say, hey, I started with this, I modified these units for this reason, these were coded incorrectly, so I switched them to this value, those sorts of things. It can feel pedantic and be kind of a hassle, but one, it'll help you understand what you did if you put the project aside and come back 6 months later. And more importantly, it provides a record for other people to know what you did as well. Okay, third high level thing. So first we've talked about not modifying the raw data. Second high level thing was keeping track of the actual changes you make. Third high level thing is thinking about how to appropriately organize your data in a spreadsheet. So there's a whole group of people who use a set of packages known as the tidyverse, and so we'll dig into the tidyverse more later. They have an ethos they call tidy data principles, but they don't necessarily, like, they don't have a trademark on these ideas, right? This is sort of good data principles in general. And so the most important principle we want to try and obey here is that we have, I guess, two sort of combo principles. One, each row in your spreadsheet should be a single observation. And then along with that, you shouldn't combine multiple pieces of information in a single cell. And so already we have this sort of high level architecture for what a tidy spreadsheet or a sort of best practices spreadsheet will look like, with each row representing an observation, and then each cell having some unique piece of information, not combining things. So like the example in this HTML page that you can look at on the R Davis site, in this case, it's a bad example because someone has taken species and sex and combined them into the same column. And so what we prefer in this case is having one column for species and one column for sex. This doesn't come up in the spreadsheet, but we will probably talk about it in weeks going forward. Often you'll see data referred, a data frame or a spreadsheet referred to as either in wide format or long format. You can take either a long data set and make it wide, or a wide data set and make it long. What that simply refers to is, as often this comes up in like a time series type context. So if you imagine that we had 30 students and we were monitoring their educational outcomes each year over time, you could envision having a row, each row represent a given student in a given year, or you could envision having each row represent a student and then you have a column for each year. I typically prefer the long format there, where each row is a given student in a given year. And that's similar to what you see in the example here. But sometimes you will get data in a wide format. So we will practice ways to take wide data and make it long, or long data and make it wide. But fundamentally, they still sort of obey the high level principles in terms of having one observation per row of one kind or another, and then not having multiple types of entries in a single cell. couple of mistakes to avoid. And this might be hard if you are really into Excel. Some people are Excel wizards and have a whole bunch of different awesome stuff going in Excel. If you're not big in Excel, some of the stuff likely won't be that hard for you. We want to avoid having multiple tables in one spreadsheet. So don't do that thing where you have like one set of data in one part of the sheet and then another set in another part of the sheet. Each spreadsheet should just be one table of data. Next thing, and this is sort of related, don't use tabs. So in Excel, right, you can have a worksheet or a workbook, and then that workbook can have like an infinite number of tabs. R has some functions that allow you to read in different tabs of a spreadsheet, but it's a hassle, and it's not really an intuitive way to organize your data. And so if you need multiple tabs, make those separate files, separate CSV files or tab separated files or something like that. A couple other common mistakes to avoid. Don't leave zeros as blank, because zeros are a value. And so if you have 0 instead of a blank, you need to record that. And then likewise, if you have a null value or a missing value, it's important to think about how to appropriately code that as well. You don't want to use 0, right? Because 0 could be a real value. There's some guidance that's borrowed from a White 2013 article about different ways of coding this. You've probably seen some of these at least in terms of working with R. The two best practices are using either null, all capitals, N-U-L-L, or using all capitals, N-A. And there's can be some downsides in certain cases to that, but it's certainly better than typing things like none or blank or simply leaving it blank. And it's also generally preferable. You'll a lot of times see in like large administrative data sets. So like if you download something from like a large federal agency, they might have a code like -999 is like their code for a missing observation. And it's tough, that's tough to deal with for a couple of reasons. One, when you first open that up, you have no idea why some of the values are -999 or what that means. And you'd have to open up the data handbook that they've also provided, and hopefully you can access that. And it says, oh yeah, we coded all missing values as -999, right? That's complicated. It's kind of wonky. It's not necessarily helpful. So when possible, use NA or null for your missing entries. Okay, moving on for a couple other things here. Forget everything about making spreadsheets look nice and pretty. None of that formatting stuff, no conditional formatting, no highlighting, anything that like looks visual in Excel, right? We're reading this into a computer program that isn't looking at it with eyes. And so that's super unhelpful. And if you're relying upon that for anything, you're going to have a bad time as well. And so you don't want to have important things in comments or highlighting or other sort of visual formatting aesthetics, because those aren't going to show up when you read it in. And they're also not very accessible, right? Because those are sort of like extra things that aren't necessarily read in and can't necessarily be read out or printed out again. And so those aren't best practices. A few other elements similar to that. We often want to try and make sure that we are not printing something a million times if we can only print it once. And so a good example of this is units. If you have a column and you are measuring the height of plants in centimeters, you don't want to record every value as 10 centimeters, 12 centimeters, 8 centimeters. Instead, what you want to do is have it either in the header, or maybe you have a subheader that records units. And in that case, you want to say, this is height of plant in centimeters. And then each value in there is simply just a number, 10, 12, 8, 11, that sort of thing. And so one, that will ensure that when you read it into R, it recognizes these are numbers, not characters, because if R sees a set of values that is 10 cm, it's not going to think that's a number. It's going to think that's a weird string. And so it's going to read it in as a string. And then also it's just simply way more text than needs to be recorded. Whereas if you have centimeter in the column header, you can only record it once. We're also similarly, we're avoiding spaces and special characters and all sorts of things like that in column headers, and impossible in your actual data entry values as well. Okay, now we're going to pause and to focus exclusively on dates. So there's a whole internet subculture that makes fun of how Excel treats dates. And it can be funny sometimes, but there's also, if you go online, you can find lots of stories of heartache and anger and woe about how Excel seems to have this passion to take anything that resembles a date and turn it into a date, or things that aren't necessarily, or things that are date and turn into something else. And it's always a bad time. That's why often people simply don't use Excel. So often when we talk about spreadsheets, we're really specifically referring to CSV files and tab separated files. CSV stands for comma separated values, and tab separated values stands for, oh, sorry, I just spelled it out. It's tab separated values. And so what that is if it's essentially a plain text file, and if you have a comma separated data set, each row is simply a line in that text file, and then each entry for each column is simply separated by a comma. So it's really easy for machines to move those in and out. It also means the dates aren't getting garbled. So conversely, if you have like an XLX file, this workbook, as you look through it, shows all these different examples of ways that Excel gets kind of weird and transposes dates in ways you don't want. But so at a high level, couple principles to just avoid that kind of heartache. One, don't let Excel handle dates, right? So use CSVs and TSVs when possible. Two, consider having columns for each unit, right? So if you have a column for month, that can simply be 1 through 12, year similarly, day similarly. Then Excel doesn't have the opportunity to take those dates and go crazy with it because it never finds all three parts together. And so in general, right, so the two things is, one, don't let Excel touch your dates, and two, use separate columns if need be. Okay, so I think we've covered all of sort of the important things about spreadsheet best practices and how to help spreadsheets play nicely with R. I'll let you cover this quality control stuff on your own because I think that's a little more idiosyncratic. I tend to work with a lot more administrative data where I'm taking it from other people and cleaning it up, or sort of like scraping it from other sources. So some of this might be more relevant if you are actually like having undergrads like write down data for you. So I'll leave that to you. And then lastly, mentioned this already, right? We're often interested in CSV and TSV files instead of XLS files. And so go ahead and export your data in that fashion as well. There are ways to make Excel shoot out an XLS file, but we'd prefer you not to. And so it's really simple to say write.csv, and that's the function in R. It's write.csv, and then you put the file name in there, and it will simply save a CSV file of your spreadsheet, and we'll show you similar ways to do that with a tab separated file as well. One note about tab separated files, you often won't see a .tsv ending. Often tab separated files are saved as .txt, and so it'll look like just a plain text file, but you can encode a tab separated file in a txt file, and it'll simply have that tab separation format. And when your computer reads in that .txt file, it should recognize in R that those are tab separated. Okay, well, thank you. And let me know if you have any questions. Please do try out the exercise. We will do that in class as well, but at least sort of spin that up and see if you can break something and get an error message, at least to know that you're on the right track. All right, thank you.